Hi, I'm John Paulraj, and in this video, we will continue to solve question number 2 from May 2025, paper 3 for IB Math Applications and Interpretations. This is the time zone 1. Let's get started. So we are continuing from F. Okay, this is 2F, and we just concluded in the earlier part. I'll try and link it. And of course, if you're following it on the playlist, you'll know which one we're talking about. We concluded the earlier video by saying that we are going to conduct a one sample paired t-test, one sample, okay? Just one sample, because we're looking at the differences of the weights, not the two samples as such, okay? So 2F is about performing the test at that 5% significance level, stating your conclusion in the context. 6-pointer, so you got to be very careful how you do that. The first thing, of course, in your written work, in your written answers, you should write down, copy down the table, but you should also write down, make a column. Okay, this might not be so clear here. You should write down the differences, okay? The differences. The differences need to be written down, and that is what we are looking at. Okay, so this needs to be copied down. I'll show it on the calculator, but you got to make sure that you write that in the answers, okay, in the answer script. So this is 2F. Let's just lay down the answer. 2F. Okay, the first thing, as I said, make sure you copy down the table. I'm not going to do that. My videos are getting too long anyway. So that table, that A, C, D, E, F, G, H, and I'm talking about both the before, the after, and the differences. This is what needs to be additional put in, okay? So that is a column that these two are you just going to copy down, but this one needs to be computed, and the calculator is going to do that for you. You just have to copy down. So I hope you can see. All right, this needs to be done. I'm just writing do this, okay? Equally important. And then after you do that, you got to write down your hypothesis, okay? So you said we will use one sample paired t-test. Okay, that is clearly mentioned. You can write down the null hypothesis as mu is equal to 0. Mu d, you can write down mu d for the differences. Mu of the differences is equal to 0. Okay, and you can say the alternative hypothesis is that the mu d is greater than 0. Okay, and then maybe you can also write down that mu d. What is it, mu d? Mu d is basically the mu after minus the mu before. Okay, so basically what he's saying is that the mean weights of the eggs, there is no difference, is what you're saying in the null hypothesis. And when you say greater than 0, it means that there is some difference. Okay, there's some difference after. That's the null. That's the alternative hypothesis. Okay, so let's just jump to the calculator right now, and this is where we were at. If you recall from the earlier parts, we had already introduced the weight of the 10 eggs, right? This was the sample of 10 eggs. Yeah, this is a sample of the 10 eggs earlier. This is table 1. According to the question, this was table 1, and those entries have entered as list 1. So whatever you are comfortable with, I'm going to call it list 2. You can call it after and before, corresponding to this question. I hope you know what I'm talking about, okay? So in this particular question, this particular table 2, so there's a before after. We're going to enter it as I'm going to enter it as list 2 and list 3, but be careful what you name them. If you're using the TZ1 Inspire, you've got to choose a correct list. The list 1 that I showed you earlier actually was referring to this particular table 1. This was the randomly selected 10 eggs, okay? But this was the study done, the before and after for the 8 chicken. Yeah, the 8 chicken before and after. So be careful how you enter that, is what I'm saying. So I am going to enter it as list 2 for the before. All right, so 53.8. This part, boys and girls, students, if you're watching this, as important. When I think I've told you before that it's not just about the entering even entering on the calculator what the values you enter is actually as important. 53.8, 51.5, 49.3. I could have actually easily just entered these values, kept it ready so that but I want you to know that it takes time. I want you to know that, even I can make mistakes. And at least from that, I wanted you to pick up your calculator and do it, because sometimes what happens is that we just think learning means watching a video and looking at your marking scheme available. But pick up your calculator, because even these errors are possible, quite possible, that just by entering, or like I said, it just takes time. That's a reality. It's a good reality check to have before the exam. 52.3. Okay, where am I? 46. So if you see me making mistakes, you should say, "Arey, we are all making mistakes." 51.2. And it's not just making mistakes. As I said, it takes time. Okay. So this is, as you can see, just 8 entries here. That was the earlier table. List 3 is going to be my after. Okay. So this is 55.1 and 51.9, 50.0, 54.8, 47.3, 53.5, 52.2, and 54.4. Okay, I hope I got everything right, 8 in all, and I hope I entered everything correctly. And we are performing on the differences. So my next list, I'll just call it differences this time. Differences this time. And you know what, you can actually write down the formula. Okay, you just want C minus B, the column C minus the column B. So here we can just say equal to C minus B, and the calculator will do that for you. Okay, so literally you don't have to do the calculations. This value I want you to copy down. These values is what I was referring to when you want to copy down, that particular row. If you have entered and made a new table here just like that, that's the value, excuse me, I want you to copy down here. Okay, along with the before and after scores, the differences, this one I'm talking about. Okay, I want you to copy down right from there. So the calculator will do that for you, and this is where we are going to perform that one sample pair t-test. Okay, let's just go back to our calculator, and here we are on the menu, statistics. As you can see, the earlier video I performed the test in the on the calculator page. Now on the listen spreadsheet page. Okay, you could do it either way, of course. Just wanted to show it to you. Okay, so one sample paired t-test. Here we go. This is paired. In that way, the data is, it's input of the data. The data is the differences, by the way. So this one we'll take it as 0, as I have mentioned here. The difference is, saying that there is no difference. The list is coming from a list called differences. Okay, frequency is 1. Alternative hypothesis, we want it to be greater than mu naught, because if mu naught is 0, greater than mu naught suggests that there is a difference. There is a difference. That means after the feed, the mean weight of the egg is greater than before the feed. First results, this can be D. And if you want, you can shade and see, the curve and all. I'm not going to do that right now. Here we go. This is the test results. Okay. And we got the T value as 2.16. And what's more important to us is that 0.034 is the P value. 0.0337 or 0.338 is up to 3 SF. Okay. 0.0338. I'm going to write that thing down. Okay. So I will say on my answer script, I'll say using GDC. And we have already indicated that we use the one sample pair t-test. Okay, and we will say using GDC, we are getting the t value as 2.16, and the p value we are getting as 0.033. I'm going to write 3SF. Okay, because that's the general nomenclature. Okay, so even though the calculator, as you can see, has rounded off to something, I don't know what it is. Let's quickly check. It actually says 3SF, but yeah, not quite 3SF. Here it is 0.0338. Okay, make sure that you write your answer to 3SF, and then you can make your argument, because you need to compare. So you can say since the p value 0.0338 is clearly less than 0.05, we say there is sufficient evidence. There is sufficient evidence at the 5% significance level level to reject the alternative hypothesis. Okay, and the question said in the context, we need to, you need to make the conclusion in the context. So we got to bring it to the context, okay, not just with these symbols. H naught is being rejected. That means the difference is not zero, which means you are going to, don't literally say we're going to accept, but we are going to put it in the context. And what is the context? Remember, the context in the question is that there are these eight chicken who were tested, before and after the feed. The weights of the eggs were tested before and after. And if your null hypothesis, the status quo as we sometimes say, is that there is no difference, and we are going to reject that null hypothesis, so we can say that for these eight chicken, you can be as specific as possible, right? Playing it safe. For the sample, for the chosen sample of eight chicken, for the chosen sample of eight chicken at the 5% significance level, there is sufficient evidence that their mean egg weight has increased due to the special feed. What was it called? Chick something, right? Give me a second. Always answer to the context, okay? So this back and forth, feeding is chicken. Chick crackle. Let's just write that thing down. Chick cracker. So you've been as specific to the context as possible. You said for the eight chicken, because it was being done for the eight chicken at the 5% significance, there's sufficient evidence that their mean egg weight has increased due to that special food, that special feed food, whatever, chick crackle. All right, now let's move on. What's the next one? From the next village, Farmer Ray offers Farmer Giles a random sample of 10 eggs from his own chickens and requests that Giles carries out a t-test to see whose farm produces the heavier egg, or the mean weight is heavier. Okay, that's what Farmer Ray from the nearby farm comes to check out. Okay, he wants Giles to conduct a t-test. Farmer Giles recalls from his statistics degree. So now you can see why he's being so scientific. I think I mentioned that, okay? He has done some statistics course. That the t-test is only valid if both population variances are the same or near about the same, okay? Because there are two samples this time. One is coming from Farmer Giles' farm, 10 eggs from his farm, from his chicken. And he wants to see whether we can do the t-test, and it's valid. The two sample is only valid when their population variances, both of their population variances are reasonably equal, approximately equal. They should be around the same. So what is the question now? The question says, given that Giles uses his data from table 1, okay, good that we entered in the calculator, calculate the unbiased estimator for the population variance for his X. This is just 1 point, okay? So clearly we can just jump to the calculator. It's just 1 point. We can use the one variable statistics on the calculator. I'll just show you, and then I'll show you how to write this, how to, write that thing on the exam. So here we go. As I showed you before, that list one was actually table 1 entries, 10 entries there. So we can just perform that list there, and therefore it becomes, and bring it to, bring your cursor to the first open block, okay? Nothing is written there, and there you can go and do menu statistics, one variable statistics, stat calculations, one variable statistics on that list, okay? On the list which is called list 1, I believe. Label it correctly, okay, so that you will remember what you're doing. Frequency 1, category, we don't want this one, okay? First results can be from G, okay? And then we can say, okay, so this is one variable just done there. This is your mean from there, 52.7. And what are we interested in? We are looking at this one, okay? This is your SN minus 1, okay? 1.55, okay? This is the standard deviation. We want something else, right? What does the question say? We want the variance. Can you see that? We want the variance. Calculate the value of SG square, the unbiased estimator for the population variance, okay? So basically the square of this value, the square of 1.55, and if you actually click on that cell, you'll see the whole digits 1.54, blah 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 blah. Typically I don't like to round off. Okay, I mentioned that in the previous video that it will compound the error of rounding off. So this is the value, this is the unbiased estimator for the standard deviation. We want to square this. So what we're going to do is that we are going to come back to the calculator page. I'll show you how to locate this. Okay, this is the calculator page. Oh, it mentions here also, right, when we did that. Okay, oh, this was for the confidence interval test. Okay, that time itself it identified 1.55. Can you see that? 1.55 was identified. So even without doing the one variable, you could have actually referred to that. I forgot this was already done before. But anyway, 1.55. How to identify that? So you can go to the variables tab here. Okay, and you can just look for SX as it says. Okay, so you can look for this wherever it says stat.q3x. Q3 is the quartile 3 for that list. So stat dot, we're looking for SX. Okay, not SSX, SX. There you go, stat.sx. Can you see that? That's going to be my unbiased estimated, this value. So if you want, I can just show it to you. Okay, can you see that? That's the one. And if you bring that value down, that's the value here. So if you want directly, you can square this value. All right, it'll be 2.39. Or what you could have done is that you could just go on here and you can pull out that, you could have pulled out that variable, square it. Both ways you could have got the value. Okay, 2.39. Okay, up to 3 is if that the right value, always a good thing to check. 2.39 indeed, and this is just for 1 point, but I explained it to you, so I can come back to my calculator now. My answer is here. This is 2G. All right, 2G, and we can say using one variable stats on GDC. You can say, what was the notation? S from a Giles, the square is approximately equal to 2.39. Okay, that's good enough. Okay, now 2H. I think this is the last part. Let's just do that and try and complete this question, even though the video might seem to be a little longer. Okay, let's read it carefully. But okay, he sets out to determine the maximum value of SR square. Okay, SG is what we found out. The unbiased estimator for the population variance for raised eggs. Okay, the same thing that we just found out here, because we don't know the data from there. Okay, we don't have any data. We just are given that he's given him 10 eggs. So he sets out, he meaning Farmer Giles, he sets out to determine the maximum value of the unbiased estimator for the population variance of raised eggs, for which the t-test is considered valid. Now remember, the validity, as we saw before, it's only valid if both population variances are almost identical, almost same. All right. So he sets out to find out what should be the maximum value of the unbiased estimator for raised eggs. Okay, for which it is valid, for which the t-test will be valid. Okay, because they want to conduct a t-test. To do this, he uses a test called the f-test. F-test. The test statistic for the f-test in this case, that's the formula given. F is equal to SR square divided by SG square. SR square is the unbiased estimator for raised eggs, and SG square is the unbiased estimator for the variance. Unbiased estimator for the variance for raised eggs, unbiased estimator for the variance for Giles' eggs. You can always have unbiased estimator for other parameters, also statistical parameters that we are checking. Okay, more on the theory some other day. The critical value at the 5% level for comparing the two samples of 10 eggs is this. This is the F critical, the F test. So the question says, determine the maximum value of SR squared, the unbiased estimator for the variance of raised eggs, for t-test to be valid. So what do we have? Let's just do this. I'll do it here. Okay, so this is 2H, 2H, otherwise I'll be scrolling up and down. So what do we have? We got the value. The F statistic is defined as SR square over SG square. We want the maximum value, right? The maximum for, he said the maximum for SR square. So we clearly know that this must be less than, this should be less than the critical value. F critical value given there. Okay, so SR square is what we want to find out. This is possible, only this, why I wrote this thing, by the way, why I wrote this, only then it will be valid. This is the condition for validity, because if it is more than, even if it's equal to, if it's more than, then you're saying that the variances are not equal. Okay, so and if it's and if you say that the variances are not equal, then the t-test which they want to use is not going to be valid. Okay, so for the test to be valid, this is the condition that it must be less than the F critical. So which means SR square should be less than F critical times the SG for Gael square. Okay, so this value we've already calculated from the calculator. We just put it up there. So which means SR, the maximum value for the unbiased estimator for the variance for raise eggs, the 10x that, okay, is F critical is 3.1789 times the SG square. What is the value you got? It is 2.39 to 0.39. I think that was the up to 3 SF. Okay, so once we do that, I think we are through, and I'm going to go to the calculator to do this. Okay, hope this is clear, and just jump to the calculator now. So this value is already there, good, and I'll just multiply this by 3.1789. Okay, and when I do that, I get the value of 7.6. Let me just bring back and say 7.60 is up to 3 SF. Okay, so I'll just write it as 7.60. So we say SR square must be, the maximum value is 7.60. Okay, that's basically what you have concluded, that the maximum value for SR squared for the t-test to be valid is 7.60. Because if it was, as I said, if it was greater than the F critical, then both those variances from both the populations will not be equal. That's what the condition, remember, the only way if it's variances must be equal. Okay, so this kind of completes not just question 2, but the entire paper, paper 3 times on 1 for IB Math for May 2025. So I hope that you found this video useful. If you did find it useful, make sure that you like and share this video with a friend, subscribe to my channel, and if you do visit my channel, you'll find several other videos there. Do check them out, and if there's any question, any concept, you know, anything that was unclear you want me to answer, do mention that in the comments, and I will make a video for you.